Hi, welcome to this video on graphing linear equations. The first thing we're going to do is graph the equation y equals 4x plus 5. So we're going to go to graph, type it in using this button here for x. You can't use the plain letter down here, we need the variable button, plus 5 and enter. We'll draw that and there is our line. At the moment you can see it's not really on the screen that well, so we're going to have a look at the view window. Usually you need to press shift to access the yellow words on the calculator, but in graph you can just press straight to F3, it takes you to the view window. You've got some preset options here. We've got the initial, trig and standard. So the initial one is really useful because if we go back now to our graph, you'll notice that the grid lines are square, which means we have the same scale on the x-axis to the y-axis. We can change this if we want to, so if we wanted we could make it -3 and 3 on the x, and we'll draw. And so maybe if I was graphing something and this is the scale I'd chosen, then I could sketch it accurately, but you can see how it could influence the way we think of the slope of this line. So it can, whereas initial will show us an idea of the slope. The next thing we're going to look at is a few functions we can do under graphing, and this is all under gsolve. So if we press here, we've got a number of options, and if we press across, we've got a couple more there. The first thing we're going to do is finding the x and y intercepts of this line. So we can see we've got a y-intercept button here, so if we press that, when x is 0, y is 5, which is off the screen at the moment. If we go back to gsolve, you'll notice there's no x-intercept button. However, we can just do an x calculate when y is 0, and that will give us an x-intercept of -1.25. It can also be done for any number, so for example, we could do a y cal when x is 2, and it tells us that y equals 13. If it says an error message or out of domain, sometimes it struggles if it's not on the screen. This one isn't, but it's worked, so you may need to increase your view window if you have any problems. Okay, the next thing we're going to look at is solving an equation. So if you have an equation 4x plus 5 equals 13, that is simply meaning that y is 13, and so the answer is actually x equals 2. So we've solved the equation for 4x plus 5 equals 13. Another way to do that is by going into equation and solver. You can see I've actually entered it in here before because I was practicing. I'll just show you again. 4x plus 5. You need to use the shift button to get to this equals here, to type it in as an equals. Enter, and sometimes the old answer comes up here, so just remember to press solve each time. So x equals 2. Okay, back into graph. The next thing we can look at is intersecting with another line. So let's put another equation here. Whoops. We're going to put in -3x plus 7. They're both selected here. If I just wanted to show one of them, I could unselect. But I'm going to put both of them on the screen. It's out of the view window there, so I'm going to make the max 15. And now we can see that intersection here. And if we wanted to find those coordinates, I go gsolve, intersect, and there are the coordinates. Okay, the last thing we're going to look at is, back to this original equation, we'll just have him on the screen, is the slope of this line. If we go to trace, we can actually trace along any point here when x and the answer for y. And we can show what the slope is at any point here, and at the moment it's not showing. So I'm just going to go shift, pressing menu, which goes to the setup. I've got all these different options. We want to go to the one called derivative. Derivative means the slope at an exact point. So if we turn that on, go back to our trace, you'll notice we have this dy by dx. And that means slope. So the slope is 4. And that makes sense because our equation is 4x plus 5. We know that the slope is in front of the x. And if we move along the line, we'll see that the slope is always 4 because a linear equation has a constant slope. If it was a quadratic or another type of graph, we might see that slope changing every time we move along the graph. Okay, that concludes this video. Thanks for watching.